Hi and welcome to Unit 1 Topic 3, Video 5, Proof by Contradiction. In this video we're going to talk about the essence of proof by contradiction by doing one of the most common examples of this particular subtopic and one of the most common proofs you'll find in textbooks and other places around the internet. So proof by contradiction is done by proving that a statement is true by proving that the negated statement is false. Now, the way we do this is by making an assumption that the negated statement is true and then contradicting that assumption. So, let's have a look at this standard proof that root 2 is irrational. So, of course, we're going to assume that, in fact, root 2 is rational. And therefore, we're going to say that root 2 is equal to a over b, where a and b are integers. So a rational number can be written as a fraction. But we're also going to assume that a over b are coprime, a and b are coprime, and what that means is that this is a fraction in its simplest form. So it's not 3 over 6, so I should write that out. A and b are coprime. It's not 3 over 6, that would be written as a half. It's not 7 over 14, that's not a great example. Maybe 65 over 13 would be another one that could be simplified. So this is the most simplest form of this fraction. Now if I square both sides, I get a squared over b squared, it's root 2, which gives me 2 is equal to a squared over b squared. Now remember, we've made the assumption it's coprime, that we have simplified this fraction as much as possible. Over a equals a squared, and therefore we get the clear fact here that a squared is divisible by 2. And this means that if a squared is divisible by 2, then a must be divisible by 2. And that is almost certainly a proof that you've done as part of your direct proof work. If a squared is divisible by 2, then a must be divisible by 2. Okay. And of course, it comes from the fact a is an integer. So therefore, we could say, well, let's let a equal 2n, where n is an integer. So n exists in Z. And so we get this. 2b squared is equal to 2n squared. And so 2b squared is equal to 4n squared expanded. And that means, of course, that b squared is equal to 2n squared. And therefore, b squared is divisible by 2. And that means that b is divisible by 2. But that means that both a and b are divisible by 2. And therefore, a over b is not fully simplified, or a, b are not coprime. And this, simplified, this is a contradiction. It contradicts the assumption. Now you can do this exact same proof for any square root that you know is irrational, root 3. Not root 4, of course, because that's just equal to 2, so it actually is rational. But we've contradicted that root 2 is rational, and so therefore root 2 is irrational because it's not rational. And then we can do the QED, or as required. So this is a really standard, typical proof, and it's a good example of the process that we follow. So just quickly on that process, steps for proof by contradiction. We assume that the thing we're trying to prove is actually false. Then we use the assumption to show that this cannot work, and then we conclude that it must be true. So in our next video, I'm going to show you another example of this. See you then.